Um, so this is extra credit for Unit 5, and Unit 5 dealt with similarity. So take a look at this first example. It says Lainey wants to calculate the height of a sculpture. She places a mirror on the ground so that when she looks into the mirror, she sees the top of the sculpture as shown. What is the height in feet of the sculpture? So if you notice in our diagram, I noticed two triangles. I noticed a triangle here, and I noticed a triangle here. Okay. So these triangles are obviously not the same size. So what's indicating to me is that these triangles have to be similar. Okay. So in order to solve parts of similar figures, we always set up a proportion. So a little helpful hint to know that they're similar. They're just not the same size. So that's indicating to me that they are similar. And I'm trying to find the height of the sculpture. So I'm going to label it X and put it into the top of my first fraction. The side that corresponds to the sculpture in the other little triangle, the yellow triangle, is 5 because they're both the up and down part. So I'm going to say X over 5. Then, in the bottom part, we have 28 is the only other measurement we're given in the big triangle. So the big triangle was in the top, so 28 is going to stay in the top. We have to stay consistent. The side that corresponds to 28 in the little yellow triangle is 7. So I'm going to put that in the bottom. Again, stay consistent. Big triangle over little triangle, so the other fraction has to be big triangle over little triangle. And then to solve proportions, we cross multiply. So multiply those two together. X times 7 is 7x. Multiply these two together. 5 times 28 is 140. And to get x by itself, divide. So when you divide 140 divided by 7 is 20. So the height of the sculpture is 20. Okay. Another type, this is a new concept, is triangle ABC has vertices at 1, 1, 2.53, and 0, negative 3. It's dilated by a scale factor of 1/2. What is the length in units of side BC? So there's two ways of going about solving this one. My suggestion would be first plot. It's 1, 1, 0, negative 3, and 2.5, so 2.5, positive 3. My suggestion would be, 1, plot these points in decimals. Okay, so take a look at decimals. Take a look at decimals, plot the points in there, because sometimes it makes it more accurate and easier to tell. So we're going to plot 1, 1, parenthesis 1, comma 1. Then we had 0, negative 3, and then we had 2.53. So there's a little more accurate look, and again, you can use an expo marker on your OST, so you use your expo marker to connect those points. Okay, and I'm going to label as well A, B, and then C, I think. No. A, B, C. Got those mixed up. This is A, this is B, and this is C. And we want to know the length of side BC after you do a dilation of 1/2. So, what you can do here is you can then first do the dilation. So multiply all the vertices by 1/2. Replot the new points. And then find the length of your new side. That's totally acceptable to do. Here's the thing. A lot of times the points are going to, especially because you're making it smaller. If you're making it bigger, I would suggest that's totally fine. But the fact that we're making it smaller, these points are going to become more scrunched, and it's going to be harder to tell to do the math. So my suggestion would be to find the distance of the original side, okay? And that way we're not dividing things that are multiplying by 1/2 and getting weirder decimals, okay? I would find the distance of the original side and then multiply that distance by the scale factor. It's easier dealing with a bigger graph, so easier to tell. So I'm going to count this like 1, 2, 3, 4, 5, 6. So this side is 6. This side, on the other hand, we went 1, 2, and then a half. So that side's 2.5. So we do the Pythagorean theorem. A squared plus b squared equals c squared. We do 6 squared plus 2.5 squared equals c squared. Because the side we're trying to find is always our c, and then doesn't matter, make one your a and one your b. So we plug that in. We're going to do 6 squared plus 2.5 squared. Okay. Is 42.25. Equals c squared. So square root both sides. I'm going to see, because this is a decimal, I'm going to see if I get a nice decimal if I take the square root of 42.5. If I get a nice decimal, 42, actually, for purposes, we're just going to leave it as, sometimes we don't get decimals, sometimes we still get whole numbers. Do not round to the very, very, very end. So whatever you get, okay, leave it as a radical. So that's the length of that side. Then what we're going to do, we did the dilation. We want to know what the length is after we did the dilation. So we're going to do 1/2 times that radical, 42.25. And that will give me my answer. So I'm going to do 1 divided by 2 times radical 42.25. And there's my answer, 3.25. So the length of that side after dilation of 1/2 is 3.25. So that is your answer. You would have gotten that same exact answer if you did the dilation and then found the distance of that side, but again, the points would have gotten more squished together, and it would have been harder to tell. So, to me, it's easier if you just find the length of the side first, then multiply it by whatever the scale factor is. And if it's not a perfect square, leave it as a radical, and just do the scale factor times whatever the radical is, and you will get your answer. Okay? So now you can work on the extra credit practice on Canvas.